ahead and start. So two fun things to think about is one, today at 2:45 is our monthly run with computing event. So if you would like to come out for a 5K, are you coming? All right, great, excellent. So 5K, we run around the campus and from shore back to shore. So if you'd like to come and join us, great. If you'd like to, just go ahead and run your own 5K or 10K or something like that somewhere and have fun with that. And then, of course, baseball is tonight. Right? The Huskers' first game of the year is tonight, and it's on TV. So if you care about either one, if you care about running and baseball, then yeah, you'll be excited. Right? Anyway, last time we were looking at the solid principles. Right, and we got through S, which is the single responsibility principle. Just make sure that you don't have any. Just make sure that you have good modeling and good encapsulation. Right. Now, when I say good, there is a spectrum of good to bad. Right. And over here on the good end, you have variations, and that's perfectly fine. Right. There are going to be several designs that are okay, or there's going to be some designs that are good, better than others, etc. But we want you to make sure that you are staying on the good side of the spectrum and not the bad side of the spectrum. And variations over here on the good side are going to be fine. Right? You'll know that you can have different variations over here especially if you're teaming up with somebody, and you can go back and forth on those designs. I think that we should do this. I think we should do that, right? This is the kind of inheritance I think we should use. Oh, no, that's overly complicated, right? And then you can get into a heated argument and then break up. Don't do that, right? Just keep it civil and keep it professional. The open-close principle is that every unit should be open for extension but closed for modification, meaning that you should not have a bunch of if-else-ifs checking what type of object you have, or either using the instance of keyword or using the get type, right? Both of these things are bad, and maybe I should explicitly say that in the notes. Hopefully, bad, right? So bad, right? Still bad, right? Just as a reminder that those are the two things that you should not do, right? Stock stuff belongs where? In the stock class. Annuity stuff belongs in the annuity class, not out here in this big giant if-else-if statement. If you did this, then you wouldn't have any object-oriented programming at all, right? You would be back at square one where you are writing a bunch of if-else-if statements. And anytime that you add a new thing, right, you're adding another line there and anywhere else that you've used this, right? The only time that you should have to use that is when you are doing copy constructors, right? And so, for example, you need to make a copy of, what are we doing, licenses or subscriptions? Of a subscription to put on a different invoice, right? Or I forget what the other ones are, products, right? Monitors, right? This nice little monitor over here that I have. Client A, they order 10 of them. So I need to make a copy of that thing and say that the amount is 10, and I put it on that invoice. Then over there, client B, they order 20 of them. Make a copy of this, make it 20, and put it over on that invoice, right? So that they both have their own copies of these objects, but they have slightly different data because they ordered different numbers of them. Another way that you can enforce this principle is through the final keyword. If you use final when used on a variable, what does it do? I'll make this slightly bigger. Yeah, you can't change it. It makes it into, what do we call that in C? It into a constant. All right, constant. All right. You can do that in C. We're using the const keyword. Can you do that in Python? That's a good question. Do you remember? No, there are no constants in Python, right? They're just promises with me crossing my fingers that nobody changes the math library's pi to 3.1, right? And losing precision. Right? Python doesn't provide that. A final class cannot be overridden. And that's actually a very, very good thing. Let me try to do that over here. Right? New class. I'll call it better integer. Right? I think I have a different way of representing integers. And so what I'll do is I'll extend integer here to provide, I don't know, double x or fractional value. I think my integers should now have fractions, right? So 10 and then a fraction of 10 or something, right? In other words, I don't want to live in a world where there are integers. I don't believe in integers. Integers are a lie, right? Am I allowed to do something like this? Right? Well, here, I'll do that. Am I allowed to do that? No, because the integer has been made final. Let me go over to the class and show you that the class has been made final. This is it. There is no subclass to this class because this is an atomic thing, or not an atomic thing, but this is a thing that should not be changed. We all know what integers are. They are whole numbers, positive, negative, and 0. If we go and change basic fundamental mathematics, that's a bad thing. Just like it would be bad to change pi to 3.1, right? So we are not going to allow that, right? You're not allowed to extend integer, right? Or any other final class, okay? So fine, can't do that, right? By the way, you can also make a method final, right? And that means that subclasses cannot overwrite it, right? If I want to make it closed for extension, then I will say that this is final. You can't change this in a subclass, right? What's an example over here? What if we did asset and what was it, stock, right? So let's get num shares, whatever. So if I had something else in asset, right? Say public, I don't know, string, get formatted, special format, right? And I'll say return null. I don't even care about it. I'll just say return special format, right? If I wanted to especially format this thing, right? But then I made that. I want to change that into, in the stock class, I can say a very special format, right? And you can do that if you want to. But if I did it up here in the asset class and I made that final, right? Now my stock class has been broken, right? No, you cannot change the behavior because it has been closed for modification, right? And so we're not allowed to do that now, right? You can make variables, classes, or methods final, and they have basically the same meaning. Don't touch this thing, right? It is what it is, and it should not be changed, okay? That's the open-close principle. The L of solid is named for a person, Barbara Liskov. Barbara Liskov's substitution principle. And the statement is that if S, let's bring that back over, there we go. If S is a subtype of T, so T up here, S down here, then objects of type T may be replaced with objects of type S without altering any of the desired properties, right? That just simply means subtype polymorphism, right? And in Java, you can do that in many ways, in one way, I guess. For example, here's the way that we've done it so far, right? Here's a code sample. I've got an array list of numbers, I've got a linked list of numbers, which is a linked list of numbers. It is better to treat that as the superclass because I don't need any special information about whether or not it's an array list or a linked list. I do need to know that it's a list because I plan on sorting it later, right? And if it were just a generic collection, not all collections are sortable because not all collections are ordered, right? You could also do it if you did it with numbers too, right? Both of those things can be treated as the superclass, right? It's much easier to understand this if you know what violations of this principle are. And we've seen two of them already. You remember the rectangle square problem, right? Square, rectangle, and then shape, right? And if you've got a square with mutable methods that make it into a rectangle because you're changing its width, now it's no longer a square, even though it's still a square type, right? That design is a violation of the Liskov substitution principle. Don't do it. Another example would be author, director, person, right? Remember that Stephen King is an author and a director. If I had put them into this rigid hierarchy, I would be violating the Liskov substitution principle because I want to take Stephen King, who is a director, and treat him as a writer, as an author. But I can't do that because that's an invariance because of the way that I've designed this triangle here, right? So that is another violation of the Liskov substitution principle. Did we talk about the solution to that, by the way? Do I have director here? Author? I thought we did that, didn't we? A writer is what it is, writer. And it extends person, right? Now, if I did that, that would force it to be in that hierarchy there, right? The better way of doing that is like I've done right here, preferring composition over inheritance. It still has all the benefits of code reuse. We still have the person here, right? But we're not forced into this inheritance hierarchy. In fact, you can take this a little step further. This is kind of a YAGNI, but let's see. Let's go with, I don't know. I don't want that. I want an interface here. New interface. Person. There. It's already named, so personable. All right. So usually when you've got classes are nouns because they're things. Methods are verbs because they do things. And then interfaces are adjectives, right? Personable, right? This is a person basically, or it is sortable, or it is comparable. So help me out with my grammar. Comparable is an adjective or an adverb? Adjective, right? All right, you look that up. Ask ChatGPT for that one, right? But in any case, if I define an interface that says, oh, anybody who's a person, right? And I would have called them person instead of personable here. But they're going to have this method called get last name, right? Now, I'll leave that as a pure abstraction there. Right? And they're also going to have this get first name, right? Et cetera, et cetera. And this is not an ideal example. You've seen an ideal example in your Lab 5 this last week where you've got somebody who is payable, somebody who is, is a person. I forget what else was in the lab, but payable is what is good enough. So things that can happen. Okay, I'm not going to let this rest. What is it? Payable is comparable a adjective or adverb? Comparably would be the adverb, right? It's an adjective. Okay, good. Adjective. That's what I thought. So usually interfaces are adjectives, right? Because they describe a property that thing has, right? Not that it is but for all intents and purposes, it is right? So you can go ahead and make prefer to put this into either composition, or you can use an interface if you want. So that's the takeaway. Generally, prefer composition over inheritance, unless your is-a relationship is always true, right? And it's not always true with an author, director, and a person. Sometimes a person is both of those things, right? You can also use interfaces instead, right? So, sorry, I should have put this over here. There we go. There we were over. Okay. All right. There we go. All right. The I, we're solid principles, SOL, I, right? Interface segregation principle. And the principle here is that no client code, that is code that uses other code, should depend on methods that it doesn't care about. And here's a classic example. Suppose that I have a click event handler because I'm writing an Android app, or that would be tap, but click is the same thing when you're tapping your phone. Suppose it's a graphical user interface desktop then, and they've got a mouse. And I've got this thing of, I need to put code in this app on what happens if you click that button over there. So it's an on-click event. It also supports an on-double-click event. What if I don't care about that on-double-click event, right? A bad design like this would force me to do both of those things, right? A bad design forces me to implement both of these things even if I don't want to. I just want to do the first one. But because it's an interface and it defines both of these things, I'm forced to, right? I just don't want. I don't want a button that I don't care about, right? So, what would you end up doing in this case? Let me go ahead and tab that over, right? You could make it into or you could throw an exception. Throws an exception. That's kind of bad because if person double clicks and then double clicks, now an exception crashes everything, right? You could have on click or on double click call, and this is usually what's done, call click on click. So what's the purpose of that, right? Why do I have to write code that I'm forced to write the code that calls other code even though I don't care about it, right? Or you could have it be a noop, right? What was noop? What does that stand for again? No operation, right? Don't ask me why it's spelled like that, but whatever, right? No operation. No, that's why it's spelled like that, because it's no op, right? No operation, right? Instead, what you should be doing is you should make all interfaces as small as possible, right? And I've got a diagram again. I think I lost the diagram. Let's open it up again. Here it is. Right. So do you remember this diagram? The collections hierarchy, showing that there are concrete classes down here, non-abstract classes, and then you've got an abstraction, and then you've got a pure abstraction up here, which are interfaces. Some of these interfaces, like these three, they don't define any methods. The number of methods that they define are 0. Instead, they are put in there as properties, right? That these things are clonable, right? Others of these, have 1 or 2 methods, or maybe 3 or 4 methods, but they're as small as possible. You want to break this up. If I had taken all these and put them into one big giant interface, right? Now everything below it is forced to do everything. In other words, you forced a God class. You want to make sure that you're breaking these up into as small of chunks and pieces as possible, right? And so that's what Java has done here. You just want to make sure that all of your interfaces, if you choose to use interfaces, and you don't have to, by the way. In fact, you will have very, very few use cases for them in this project, in this course, but you can if you want to. Just keep them small, right? Finally, the D of solid is dependency inversion. I hate this word inversion because when I say inversion, like you're turning something upside down, right? That's not what happens here, right? The statement here is that high-level modules should not depend on low-level modules, right? And the example that we're going to look at is exemplified in our next topic here, right? All right, so let me reformat this. There, that's a little bit better, all right? So suppose that you write code that connects to a free MySQL database. You will be doing that, except it will be connecting to what's called a database, MariaDB. Because that's free, right? MySQL is not free. It's free as in, if you ever heard the term free as in beer versus free as in freedom, right? So it's free as in beer. In other words, it's free beer. You don't have to pay for it. Free, though, is in free and open source software, free of FOSS. It means that it comes with no legal encumbrances. You can do what you want with it. Free as in freedom, right? And so this is a free MySQL database, but not it's free as in beer. And suppose that I wrote a bunch of code just for that database, right? Now suppose that my project wants to be migrated, my department or whatever, they got some money, and so they can start paying Microsoft for SQL Server. That's how you pronounce this, by the way. MS SQL. MS stands for Microsoft. SQL stands for structured query language, actually, but all of these databases use SQL, right? What's going to happen? I end up having to throw away all my code, right? And rewrite everything, because all my code was towards MySQL. Now I'm switching over to MS SQL, and now I've got to rewrite everything for that, right? This is what's called why we have what's called vendor lock, right? The cost of migration is slightly higher than the cost of sticking with what we have, right? You're locked into that vendor, right? And so vendors can raise their price as much as they want, as long as they know that it's going to cost you more to switch to another vendor, right? Because you have you've tightly coupled all of your code to that one particular product or that one particular thing. Instead, what you should be doing, or what you should have done, is you should have written towards an interface, right? That each one of these databases implements. And I do have a figure for that. Again, it's not inversion because we're not switching anything, right? So here's without dependency inversion. Here's my code called package A. And my object references this object B over here in package B. In other words, it's directly using that object. I am locked into that object, right? If I wanted to go to package C instead, I would have to rewrite all of the code over here that references package B. With dependency inversion, however, I don't write it towards package B. I write it towards an interface, a generic thing in between. Package B is responsible for implementing or inheriting that interface, and now it's loosely coupled. If I want to change package B, all I need to do is throw it away and plug in a brand new one. Did I have to change any code over here? Nope, because it programmed towards this generic interface. So it's not inversion as in turning it upside down. There's this dependency, this tightly coupled dependency, and I'm pulling that apart and I'm putting something in between, an interface. And now each one of those is interacting with that interface so that I don't have to worry about package B over there. I just have to worry about the interface. A more solid example here, or solid example, right? A more concrete example here would be the following. Suppose I have 3 libraries to determine where you are in an Android application that I'm running, or mobile application. I need to find out what your latitude and longitude is to guide you to the next Pokemon station. Right? What are they called? Pokestops. Okay, thank you. All right, library A here. You can get the latitude and longitude through this static method called GPS locator. Right? Get the latitude, get the longitude. Library B actually is a native Android app that gives you a location, this Android location, and then you can pull out the latitude and longitude from it. Library C actually triangulates using cell phone towers, so it's much more accurate or something, right? And to do that, however, when you get the latitude and longitude, they're in radians, so you have to convert them to degrees if you want to. Now, without dependency inversion, here's what it looks like. Right? I have to have a bunch of if, else, if, else, if, else, if, else, if, and I've got there we go, right? I have to check, are they using library A, or if library A is available, then I have to use their code. Otherwise, if library B is available, then I have to use that code, right? Use the Android location, and then rip out the latitude and longitude. Otherwise, if it's a cell phone tower library, then I have to get the I have to call radians to degrees because they're in radians, and then blah, 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 right? With inversion, what would it look like? And there we go. I would have a generic interface that returns my location, not an Android location or whatever. This is my version of a location. And so you just get location. Now, if I wanted to write a wrapper for that Android locator, then it would look like something like this. Android locator implements locator. The get location method has that code that I had above. It gets the Android native location, pulls out the latitude and longitude, and then returns my location, my version of location. Then my client code doesn't have to care about those details. Instead, my client code simply just creates a new Android locator, this thing up here, that implements this function, and I know that I have that access to that function. I don't have to know what are the details. Does it return it in radians or degrees? Well, no, I just have to understand my location over here. Right? How much better is that than this if, else, if, else, if, else, if statements, right? Or if I just had one library, now I'm locked into that library because presumably I would be doing this all over the place, right? Dependency inversion means that there's something in between, and there should be a better, I should write my own someday, my own diagram of this because it's much easier to think of it as a man in the middle, right? Where there's a broker that is negotiating for you, right? And you don't have to worry about that thing over there. You just have to worry about the broker, right? Okay. We already did the stupid principles, right? Yeah. So, in sum, for not the solid principles, but the dependency inversion principle, inverting means simply that there's an interface in between. In general, you should prefer loose coupling. Do you remember the stupid principles? What was it? C? No. What was it? I forget what it was. Come on. I'm not going to be able to open that again. I think I've got it open somewhere already. That's all right. Let's just reopen it. A simple Google search will find it. Oh, there we go. The T. What's the opposite of loose coupling? Tight coupling. Also known as strong coupling. is a generalization of the singleton issue, blah, blah, blah. If making a change in one module of your application requires you to change another module, then coupling exists. They're too tightly coupled. You want to make sure that you're removing the coupling and making them as separate as possible, because then it makes it easier to exchange parts. You find this in manufacturing all the time, right? This is why we have standards and ISO standards, so that you don't have to have a specialized motor to do something. You can use an off-the-shelf motor and then just adapt it for whatever you're trying to build, right? All right, so there are the stupid principles. There are the solid principles, SOLID, right? It's a nice acronym to remember. We have 25 minutes left. Any questions on object-oriented programming or your assignment that's due tonight? No? All right, keep in mind that we have help hours until 4 o'clock or so today, and then I'll be online, of course, until 9, especially because, I guess I'll be online until 10 because of the baseball game. I'll be watching that. And so I'll have my computer over there, and I will be answering questions on Campus Wire, but I will not be, I go to bed immediately after that, so, because I'm up at 5. So hopefully somebody else will be able to help, but if you're doing things at the very last minute, unlikely that you're going to find any help. Right? All right, so since we do have some time, let me go ahead and bring up the next topic, the next module, I guess. So it's not, if you, oh yeah, go ahead.
I guess I was going to ask, could you show us, because it said in assignment 1, you have like the X stream and then JSON.
Uh-huh.
I'm trying to use those for my assignment, and it's really not working well on Eclipse. I was wondering if you could show us how you use that. Pretty sure.
Okay. So let's just go with Xstream first. 2-minute tutorial. All right. And there it is. All right. So you'll have a class that looks something like this, right? You can do that, but if you read the tutorial just right after, that means that you've got other dependencies, right? So if you're getting an error like something is missing, then we would recommend that you go with the DOM driver, right? Or ever since Java 6 or something, you can go with the stacks driver, right? So are you doing it like that?
I've tried both of those.
Okay.
Neither have worked. I think it's something to do with Eclipse itself rather than.
Oh, so have you added the? You've got like a lib folder.
Yeah.
And lib. And we can download this really quick. Oops.
Yeah.
Find download.
But for some reason, it's still not recognizing.
Binary distribution. That gives me a zip file. All you're going to need is, bring it over here, lib, Xstream, probably just that one right there. All right, so let's go ahead and get rid of this for a second. Just drag and drop, copy. Make sure that you're copying, by the way, because if you just link it, then your build will not work, right? Then you right click and build path, add to build path. Did you do that?
Yeah, well, I went, I clicked the project itself and went to build path and then add external, or add jars.
Okay, build path, add external archives.
Configure build path.
Okay, and then you add a jar file where libraries.
And then I added it to class path.
And yeah, I would do it the other way. When you look at your configuration like this, does it say that it's in the lib folder?
Yeah.
Okay. And it's in class path, not module path.
Not module path.
Okay. So let's go to demo. And here I've got a person. That's good enough. All right. Let's go ahead and do the 2-minute tutorial. All right. Back. So there's Xstream. Does it compile? Import that. Import that. Oops. Ooh, is that what's happening there?
Yeah.
Okay, so it's not compiling.
When I try importing it, I get errors there.
Why DOM driver bad? All right, well, that'll work. Then I don't want to show everything.
Don't you also need like XML poll?
I mean, that's if you're doing it like this.
No, that's
Maybe.
I'm talking about XML poll.
Okay, if we also need that, then where would it be? You know, it's not in Hibernate. It's right, probably under Xstream, and then where's poll? There, right there. I'll see if I changed my workspace, which is going to take a minute here. Right. And by the way, JSON, I think I put an update on where you can find the jar files there. But there's my Cinco computers. All right, we can just look at the class path here. Lib. I've got I only have Xstream. I don't have the XML poll.
I do.
You do?
And so mine didn't work until I did.
All right, so add XML poll, see if that works for you. I'm on 1.4.20. I don't know what you're on.
1.4.21.
21? There's no way that they would have changed it. But I mean, I can show you. No, it's going to be a COM data converter. Yeah, I'm using the DOM driver, and I don't have poll. Yeah. So I'm not sure why it's not working over there, but try bringing in the other two libraries then.
Okay.
Did that work, or working on it?
Yeah, I'll try it and see.
Okay. Where was it? Change workspace. Switch workspace back to Spring. There we go. Yeah. And whatever you saw there, just ignore it. But it's not necessarily well designed. I just threw it together. But also, there's a whole bunch of other stuff that supports stuff like you saw, like a 2 students version, right? Anyway, we can while we're waiting for that, we can at least motivate the next topic of databases. It's not too common to find databases in a Computer Science 2 course, which I think is an actual positive, unique thing about our program, is that you're getting that experience like really, really early. And I think that it's absolutely necessary, because if you're going to be doing CRUD apps, create, retrieve, update, and destroy, you need a database layer, and you need it quick, right? You need it in the front of the curriculum. A lot of curriculums don't even do databases at all in the core curriculum, right? They just expect you to do it on your own or something, or through like a technical elective. And we do have a technical elective that covers databases, but it covers it at a much lower level, right? And the reason that you want to use databases is because programs are short-lived and data is not. You want a way to save that data from one run of your program to another run of your program, right? That's called persistence of data. Up till now, we've been using flat files, or like you've been doing in your project, JSON or XML, which are structured files, but they're still flat file. They're still files, basically. And that's not going to cut it anymore, right? There are lots of problems with that. Let me show you an example. Right? So here's a bunch of enrollment data. People are enrolled in CS2 or discrete math or computer hardware, right? And we've got course names for each one of those courses. We've got students, we've got NUIDs, and we've got their emails to contact them about important things, right? What are some problems with this flat file? What are some problems with representing data like this?
It has to be ordered.
So if you want to like collate everything to get CS2, yeah, you have to order it, right? Means I have to open up the entire file, I have to read the entire file, and I have to sort it and then put the file back or something, right? Or make a copy of it, and then filter out just the CS2 students. In other words, to process some data, I have to process the entire file, right? So that's a drawback. What about the data itself? What about Tom Waits there? What's his ID? 11223344. But what about that? Waits, comma, Tom, and it's all lowercase, right? What about his emails? Twaits@email.com, and then he has a different email up here. That's why we have that record. He's not enrolled in any class in that record. That's just there to indicate that he has a secondary email. Kind of stupid, right? There must be a better way. What about John Student? Sometimes he's J Student, and sometimes he's John Student. What about, there's nothing wrong with the course names over here, except that what? What happens when we've got missing data? Is it an empty string, or is it null? Or is it none, right? Multiple ways of representing missing data. But also repetition. Everybody who's in CS1 or CS2 here, CSCE 156 and Intro to CS2, those are repeated every time, right? So if I've got 100 students in that course, then that data is repeated 100 times. It opens the door for anomalies. What if I changed one of those records? Now the other 99 are out of sync, right? If I wanted to change one record, I would have to go and touch all of the records, right? All of those are huge problems with respect to databases, right? It's a terrible file to consolidate data, right? Files can only be processed by one program at a time, because have you ever tried opening up a Word file and then deleting that file? Is it going to let you do that? Try it sometime, and it'll say, nope, there's a lock on this file because a program is using it. So if you've got a program using a file, that prevents all the other programs from using a file. Think about distributed computing. Is it possible? Would we like to live in a world where one person could use Google at a time? Right? The use goes away immediately. Usefulness goes away. Right? The data is repeated unnecessarily. Right? Consistency issues. Right? There are lots of data anomalies. Right? Missing data, etc. Right? There's integrity issues. There are different ways of representing missing data or non-existent data. There's no enforcement of rules, right? If I didn't have it there, but what if I had a GPA, right? There's nothing to stop you from making it into hello instead of 4.0, right? Because why? It's a text file. It's just a bunch of text. Right? Organization problems. It's not sorted in any way, so I have to do the entire file if I just want, one list of CS2 students. Something to think about, though, else that nobody thought about was security. Right? If my program can read it, then it can read everything in there. What if there's some section of that data that should not be read because you're not the instructor for that course? You shouldn't know who's in that course, right? And you shouldn't know what their emails are because we don't want you contacting them, right? There's no way to enforce security except that it's an all or nothing thing. You can read the file or not read the file, right? There's formatting issues. There are no types, et cetera, et cetera, et cetera. So flat files are terrible. So 1970, the solution comes along, right? RDBMSs. RDBMS stands for Relational Database Management Systems. Right? Where are you in 235 right now? What are you covering sets? Have you covered relations on sets yet? So here's a set A, right? B. Right? A is equal to, say, A, B, C, right? And let's say that B is equal to 1, 2, right? Okay. Have you seen this before? Cross B. There we go. Okay, not cross, times. There we go. There we go. What is that? Tell me what that is. Oh, I should have been escaping these.
It's like A and B.
What do you mean by and, though, in this case? It's not going to be a union. It's not going to be an intersection. What is it? It's pairs. A1. You also have A2. What else do you have in there? B1, B2. B2. What else? C1 and C2. All right. That's a relation. When I take a set and I multiply them out, that's what times means there, then that's what's called a cross product. Cross product, right? And if you have R is a subset, so you've seen this, right? Subset equal, there we go, right? Subset equal, okay, A, there we go. A times B, there we go. So R is a subset of that. In other words, if you just do the cross product, that's all the pairs. But if you were to enforce a relationship that only certain pairings are valid, that's called a relation. And that's where we get the term a relational database management system. So eventually you're going to talk about that because relations can be reflexive, irreflexive, transitive, symmetric, anti-symmetric, all these different types of relations, right? And you'll realize immediately, oh wait, that's how databases work, right? Because of our man Codd. 1970, Edgar Codd at IBM came up with this idea, right? And so what is it, almost 60 years old now, right? And the key aspects are that data is stored in tables rather than in separate tables rather than in a file. At the end of the day, everything's stored in files. But these are more structured, right? Tables have columns and pieces and records. And so columns are pieces of data and rows are records. What does that sound like, by the way? Sounds like this table over here, right? But that's just one table. A relational database management system is going to have separate tables. What else does it sound like? What else has columns and rows? A 2D list and everybody's favorite Microsoft product, Excel, right? An Excel sheet. Excel sheet is a spreadsheet, is not a database. The equivalent of a database in Microsoft world would be Access or SQL Server, right? Every column has a type and a name. Every row corresponds to a single record, right? Records in a table are uniquely identified through PKs or primary keys, right? So we'll shorten that up to PKs. Right? Now, here's where the relational database management system comes into play. Records in different tables are related to each other through foreign keys, or FKs for short, right? Foreign keys foreign keys define relations of like a one-to-many or many-to-one, right? But before we do that, let me go ahead and show you what it looks like when we've fixed this table. There we go. There. So going from a flat file, this is the same data that we just looked at, by the way, but now it's been separated out into different tables. What is this table responsible for? People, persons, students, right? What is this table responsible for? That's classes, right? In other words, I've separated things out into proper tables. Sound familiar? Object-oriented programming, separate things out into separate objects. What is this table for? Emails, right? And what is this table for? It brings together these two tables. That student 5 is enrolled in course 11132 in fall 2011, right? That's called a join table. It relates these two tables together to bring everything together, right? And these little, these are chicken feet here, all right? Usually there are 3 of them, but that's the best drawing I could get there at the time. There's a one-to-many relationship. What does that mean for a person? A person has how many emails? Up to many, right? It could have 0, 1, 2, 3, 4 emails, right? And there's a one-to-many relationship. What about this? A one-to-many relationship and a many-to-one relationship. One person can be enrolled in multiple courses, and one course can have multiple people in it. Right? So that's a many-to-many relationship there. Right? All right. So that's where we'll pick it up on Monday. With that. Otherwise, did you get it resolved?
Yeah, I got it figured out.
So what was the issue?
So I think what I was doing was, I think I was just going to the wrong spot, adding it to build path.
Oh, okay.
Because I noticed when I did it this time, it made a new thing called reference libraries, and it didn't do that before.
Okay.
So I think that was what was going wrong.
There, that's why. Build path versus class path. Class path just says that it's a reference somewhere on your system. Build path says when you build this, then, or when you compile it, it needs to be here or something. That's not a great explanation, but that's probably what happened. Right? So when you add a jar file, make sure that you're following the instructions in the project overview appendix, and that's how you should be adding them in clips. Right? All right, no other questions? All right, then have a good